So we are going to have 2x cubic plus y cubic everything dx is equal to 3xy squared dy. Taking that part on the other side. Now, then we can divide both sides by 3xy cubic so that we are going to have our dy over dx is equal to this part here, which is 2x cubic plus and divided by 3x y squared. So we can write this equation that way. Next, we want to divide it by x cubic. So when we divide it by x cubic, here we are going to be left with the 2 plus y cubic over x cubic divided by, you can see here we have 3x and y squared. So it means we will be left with the 3y squared over x squared because one of the x has cancelled out. Then now the next thing, now we are going to let what we are going to do, we are going to let our u be equal to y divided by x, meaning that from here or our y is equal to ux. We differentiate this equation, dy over dx is equal to u plus x du over dx. We can call this equation here equation 1. This one we can call it 1. We can call this other one equation 2. We compare 1 and the 2 to obtain the following. So we are going to have u plus x du is equal to dx, which is equal to, here you have y cubic divided by x cubic. Our u is y over x, so substituting there, that's why now here we are going to have u cubic, everything divided by 3 u squared. Why? Because of what we have here. Here we have y squared over x squared, which is, so we get you bring the terms with the u together, so you can take u the other side. So this can be written as x du over dx is equal to 2 plus u and by u squared minus u. Then is equal to 2 u cubic minus 3 u cubic will give you minus 2 u cubic divided by 3 u squared. Now from there, now we separate the variables. We separate the variables here. How do we separate the variables? We are going to multiply by this denominator. So we are going to have 3 u squared divided by this part here divided by 2 minus 2u cubic. We introduce integral signs, both signs. We introduce the integral signs, both signs. So this can be written as we can factor 2 on the denominator so that we have half integral of 3u squared divided by 1 minus u cubic du is equal to integral of dx over x, negative half of 3u squared divided by u cubic minus 1 du is equal to integral of dx over x, which implies that you can multiply both sides by -2 so that we are going to have integral of 3u cubic divided by, integral of 3u divided by u cubic minus 1 du is equal to integral of -2 dx over x. So to integrate the left hand side, we are going to let our denominator, which is u cubic minus 1, to be equal to, let's say, even n, so that now we are going to have 3u squared du is equal to dn, where you have 3u squared du, you substitute it with the dn. So you are going to have integral of dn divided by n is equal to -2 integral of dx over x. Then from there we can integrate both sides to get natural logarithm of n is equal to -2 natural logarithm of x plus constant c. Then we substitute it back, so after the value of n, natural logarithm of modulus of u cubic minus 1 is equal to -2 natural logarithm of x plus natural logarithm of c. Now, constant c, when you have constant c and the natural logarithm of c, the result is constant c. Then from there we substitute back the value of u. We know that but u is equal to, we had let our u to be y over x. So we are going to substitute back y cubic over x cubic minus 1 modulus plus natural logarithm of x squared. I have taken -2 natural logarithm on the left hand side to make it positive, and I have used the rules of logarithm to write it as x squared. This is equal to natural logarithm of c. Then at this level, we can also apply the laws of logarithm to write on the left hand side everything under the same logarithm. So this will be y cubic minus x cubic divided by x cubic multiplied by x squared, which is equal to natural logarithm of c. Now at this level, you can divide by natural logarithm, so that you are going to be left with y cubic minus x cubic divided by x is equal to constant c, meaning that y cubic minus x cubic is equal to xc after multiplying with x both sides. So y is equal to cube root of x cubic plus xc. So that is the solution of the given homogeneous differential equation. Now, on how to integrate, you can check in my channel so that you may learn together with me. Thanks so much for taking time to learn with me on how to solve ordinary differential equation of first order which are homogeneous. You can also check on how to solve by separation of variables on this channel, and we are going to learn together. Bye bye. See you in the next video which I upload for us every day.